So let's look at this question. Calculate the unknown value. So we have to remember our steps. Step 1, determine which side is the hypotenuse and figure out which angle the right angle is pointing to it. So if we look at this, our hypotenuse is given to us. That right angle is pointing to the 12. That is our hypotenuse. Determine which formula is needed. Well, because they gave us the hypotenuse, we're going to have to do some subtraction in this question. Now, the other two sides are A and B. It does not matter which side you said was A and which side you said was B. Okay, it does not matter. Now, where's our third step? Substitute the values into the formula and find our answer. So, because we're looking for our unknown, b squared, you can rearrange the hypotenuse formula by saying, okay, we're going to take the hypotenuse and we're going to subtract the side length that we know. So that's how we've rearranged the Pythagorean theory. Plug in what you don't know. Well, we don't know x. Okay, so that's why the b got replaced by the letter x, and that's up here in our diagram because our unknown side is called x. But then we do know that the hypotenuse is 12 and the other side length is 7. So we just plug in those numbers. 12 squared is 144, 7 squared is 49. We do that subtraction, it gives us 95. Then we have to take the square root of both sides to get that x by itself. And when we take the square root and you round, we get approximately 9.7. And again, we're going to put in units because they didn't give us any units with this example. So why does that work? Okay. There, I have another example that shows you kind of the math behind it. The length and the width of a rectangle are that and that. Calculate the length of the diagonal to 1 decimal place. Well, let's start by drawing a rectangle. Here's a rectangle. What is a diagonal? A diagonal is a line that goes from one corner to an opposite corner. This has essentially created two right-angled triangles here. We've got a little right-angled triangle that happens here, and it is, let's see if we can get our highlighters working. It's this one, so it goes there, there, there. There's one triangle, and then there's another triangle that lives on the opposite side. And it doesn't matter which triangle you use to solve this question because they share the same hypotenuse. That's not going to work. I thought that was my, oh, it is my highlighter. I just picked the skinny one. So here's our other one. That's aggressive. Let's undo that. Working with my mouse. And there's our other triangle. So we have to label this how we see fit. Well, we know that the length and the width are 15 and 12. So the length and the width. So we'll put 12 here and we'll put 15 right there. So if those are the length and the width, that means I'm solving for a hypotenuse. So when we're solving for a hypotenuse, we are going to use c squared equals a squared plus b squared. Plug in what you know. We know our a and our b are 15 and 12. 15 squared is 225. 12 squared is 144. Add them together, 369. Have to undo the squared, take the square root of both sides. The square root of 369 is approximately 19.2 centimeters, and it is centimeters because they gave us a unit in this question.